Very good.
Well, it's straight up noon on my clock, and we'd like to welcome everybody to our Iowa State Dairy Team Dairy webinar. Today's topic is dairy pest control, fun with flies, which makes you wonder about our presenter when he thinks that's the right title, but he will share why that is later on. As we go through today, if you have questions, please put them into the chat box at the end of the day or end of the program. If we have time, we may just have you unmute and share questions that way. But right now, we're go ahead and get started. Dr. Jardon graduated from Iowa State College of Veterinary Medicine. He completed his Master of Preventive Veterinary Medicine and Dairy Production Medicine residency at UC Davis. He has been in private practice and industry for 35 years and has a particular interest in transition cow diseases. Dr. Jardon worked as a dairy technical consultant with Elanco Animal Health in California for the last 11 years and is currently the dairy extension veterinarian at Iowa State University. Dr. Jardon, we're excited to have you as a presenter today. And as I always say, the podium is yours.
All right, thank you, Fred. So we'll go ahead and get started here and talk about flies on dairies. Today's talk, I always debate about how to best present information like this, but I think if we really understand the basics of where flies live and how they reproduce and the difference between the flies, it helps our control efforts. If we just have a little bit of understanding of that. So that's where I'm going to aim most of my effort today, is on understanding the main flies that affect us. But before we get started, I want to talk about the natural wonders of 2024. So this was last week I got to go down to the eclipse in Missouri. This is my son and my grandson watching the eclipse, and this is a picture my nephew took. And then we're talking about flies today, a little bit of fun with flies, but we're going to talk about another insect. In 2024, it's kind of this double brood of cicadas coming up. There's this 13-year brood, which is this brood 19 from the south, and then this brood 13 that's kind of in mostly northern Illinois, and that's every 17 years. If you multiply 17 times 13, you get a big number that goes all the way back to 1803, when Thomas Jefferson was president. Was the last time these two broods merged together. So it's there's a little spot here where you can go learn more about it. And I want to thank Erin Hodgson for helping me learn about those things. She's our state entomologist on the crop side. But let's get started now. So I'm a Wordle fan. I play it every day. And as I get ready for a talk like this, I start with the word like flies, and it ends up being a pretty darn good Wordle. Last Sunday, the word was blimp, and flies got me there in two guesses. Those of you that play Wordle know that that's not easy to do. All right, so just a little bit about my history with flies. I grew up on a farm in Southwest Iowa, and I hated flies. I mean, we had them on our farm, and they'd get on the calves, and they'd get on the cows, and they bothered us, and they bothered the animals. And then in vet school, I learned about flies, and learned about them for a test. But then as a vet and as a nutritionist, I saw how much damage it can really do on a farm, especially horn flies and stable flies, which I'll talk about in more detail here. So then as I got to be in the profession longer as a vet and a nutritionist, I would organize meetings and I'd say, we need to have somebody come talk about flies. So I really appreciate the people, the state entomologist and other people that have been on the programs that have taught me about flies. And then I was lucky enough at Elanco to be there when they purchased Novartis and Bayer. So our fly portfolio came up. So I had a reason to even learn about it more. So that's I want to thank my colleagues there too for helping me learn more about flies and what we can do about them. So to get started here, let's just talk about the basic life cycle of a fly. It's called a complete metamorphosis. So this adult fly lays eggs, and then those eggs hatch into this thing that literally looks like a worm, right? We call it maggots, larvae, but it looks way different than an adult, hugely different. So it's most of us are familiar with butterflies and caterpillars and how they pupate into a cocoon and become an adult fly. Well, or adult butterfly. Our flies are about the same thing. So it goes from egg to larvae, and it goes through 3 instar levels there. Then it pupates into this thing that's still alive. It kind of seems like it's not, but it is. It's still alive in there. And then the adult ecloses out of that. That's the term for coming out of a cocoon. All right, so we're on the cicadas. So cicadas a little bit different. I won't spend much time today because it's off topic a little bit, but they have a simple metamorphosis. So after the egg hatches, there's this thing called a nymph, not a larvae. And that nymph kind of looks like the adult. And it molts several times. And it gets wings as it goes through these moltings, but it doesn't go through that huge life change that our flies do. When they go through from a larvae, it looks like a worm to a cocoon to the adult that flies around. And another big thing here is the time. These from 1 to 17 years. We get the annual cicadas and we get these ones that are in the ground for 17 years, which is a very interesting phenomenon. All right. So now we're going to talk about the 4 different types of flies that really affect dairy cattle. Now, there are other flies you'll see, but there's really 4 that are of economic importance and that are really the major ones that cause problems. I'm going to spend just a little bit of time here talking about their names because I think it's kind of it's telling, and I think it's kind of interesting how these names came about. So a house fly is the fly that we think of coming in our house and flying around and bugging us. Now, there are other flies that come into our house too, but most of them are going to be house flies. And if you look at the scientific name is Musca domestica, which essentially means a domestic fly. So it's kind of a fly that's kind of becoming, that likes to live with us and in our houses. Stable fly is a really interesting one. So we're going to talk about it in more detail because it can do so much damage to animals. But the stomoxis part means, stomo means mouth, and xys, xys means scissors mouth. So essentially means a sharp mouth fly. And then calcitrans means kick. And those of you that have seen these on farms and know how when they get on the legs of a cow and it makes them kick, how that makes sense. It's essentially a sharp mouth fly that makes animals kick. And the stable comes about because of where they reproduce. They're noticed that they're around stables, horse stables and stables with cows in them. So it was that's where the name came from. And as we get into it and talk about where they reproduce, that'll make more sense to you why they're called a stable fly. Face fly kind of makes sense. It comes from because they like to be on the face of the animal. But this Musca automalis just really means a house fly that we see in the house in the fall, because that's one of the places they come into in the fall. It's going to come in the houses in. Horn fly is Hemotibia irritans, and that's another really interesting name. Hemo means blood, tibia means live on, and irritans obviously means irritating. So this is an irritating fly that lives on blood, and that's a very accurate description. And the horn fly comes from the fact that they first noticed it around the horns of animals. I thought a back fly would be more likely because it lives on the back, but we'll get into more of that as we get into the individual flies. Okay, so now we're going to talk about where these animals live and how they feed and how they're different. So the face fly and the horn fly are the 2 that are really pasture flies. And that's because they reproduce in fresh manure. So as soon as a cow lays down a patty, the flies will land on the patty and lay their eggs. And the manure needs to be pretty fresh. It can't be more than an hour or so old. If it gets older than that, the flies will find a fresher pile to lay in. So because of that, house flies and stable flies don't tend to be as big a problem on pastured settings. They're more of a confined setting. And our face fly and horn fly are in the pasture setting. Now we sometimes see animals in confinement next to pastured animals that'll have a problem with them. But in general, our animals in confinement don't have a problem with face flies and horn flies because of how they reproduce. There's just not fresh manure for them to reproduce in. All right, now we'll talk about the horsefly and the housefly and the stable fly. So they reproduce in decaying organic material. And if it's wetter than 20% or drier than 80% dry matter, the animals, they don't like it, and they like it somewhere in the middle there. And the stable fly likes it maybe a little bit drier than the house fly, but it can be too wet and it can be too dry for them, which we can use as a way to help control them too. And the picture here of this hay feeder, this is kind of the classic spot that we see stable flies living in. They love the decaying feed, and they really like that when it's mixed with a little bit of urine and feces. This is stable fly heaven right there. All right, now we're going to talk a little bit about how they feed. So the stable fly and the horn fly are true parasites of cattle, and they like blood. The adults, that's all they eat. And so it's this, if you notice this mouth part up here, the one in the upper right-hand corner, that's actually on my mug here. You can see my mug. It's the same picture. It's on that mug. It's right there. It's really sharp mouthpieces that are really big and really painful. And if you've ever been bit by a stable fly, you really know it. You know, a mosquito will bite you sometimes and you kind of look down, oh, the mosquito, that's annoying. These things, there's no doubt. It's a huge mouth part. This thing rips into the flesh and causes a really painful bite. Hornfly is also a painful bite, but it's a lot smaller, and they drink less blood at each time, but they feed a lot more times per day, which we'll get into here more when we could talk about each individual one. All right, so the housefly and the face fly are called sponge feeders. So if a fly lands on you and it bites you, it was not a housefly and it was not a face fly. They have these seemingly kind of innocuous mouth parts that kind of lap stuff up. So when they land, they'll vomit up some stuff and then they'll re-ingest that. But that's how they're getting their food. They're not drinking blood. They don't have mouth parts that'll pierce things. And so they will drink blood, but it's not blood that they got from causing a wound in the animal. All right. So now we're talking about where they live. The horn fly is kind of a special case. It really lives on the animal. That's its bedroom, that's its dining room, that's its bathroom, that's its where it eats, where it sleeps, where it drinks, everything. And it spends all its time there on the host. The other three don't spend very much time on the host. Stable fly comes in and only eats for about 2 to 4 minutes, and then goes off and rests somewhere else the rest of the day. The house fly spends maybe a little bit more, the face fly spends a little more time on the animal and likes to drink the tears and the mucus and the snot that come out of the nose, but they don't spend a lot of time on the animal. And then the house fly is really not a parasite at all. It just happens to like the stuff that's around animals. They don't really care if they're on the animal or not. So it's of these four, it's the one that's really just kind of opportunistic living there. The face fly, the horn fly, and the stable fly are true parasites. They need the animals to live for what they like to eat and drink and where they like to live. All right, so now I'm gonna go through each one of these in a little more detail. I'm gonna start with the horn fly. So in general, on the dairy side, we're not that interested in horn flies, but I'm gonna give some exceptions to that here. We consider it more of a beef cow pest. And on the beef side, it really is one of the biggest economic losses we have because they drink so much blood, cause so much worry and pain that they really decrease milk production in adult cattle. That makes the calves not grow as well that are nursing them. And it also affects the growth of the calves. And then if weaned calves are on pasture, it'll also affect their growth. So this fly worry is kind of a big deal. So when I think about treatment here for these, on animal tags and sprayers and oilers dust, they're really helpful in treating the backs of the animals and make it so that we can really keep the population down with those. I think it kind of an underutilized area though is the breeding areas. We can do feed. So on these, it's really hard to treat the manure other than feed throughs. But there's several insect growth regulators we can feed to these animals that'll help kill those larvae and keep them from growing. And one of the big problems people have is they don't start that early enough because it takes a while to get those initial flies, get that population started. If we start it before we start when it's still cold enough and the flies aren't there yet, is probably a good idea. All right, so it's the normal location of these flies. It's on the back of the animal, and they're always facing down. Look here, you can see those wings are on the top side, and these flies are facing down. They're a little bit smaller than a housefly, actually one about half the size of a housefly. And they're the ones when you see a whole bunch of flies on the back of an animal out in pasture that kind of raise up in a fog. That's what these flies are. Those are the horned flies. So I'm just going through a little bit of math here. Each one eats about 0.01 milliliters of blood each meal. So that's not a big deal. That's not a big loss of blood. But some of these animals can have 4,000 flies on a side, 8,000 total, and they eat about every hour, 20 to 40 times a day. So if you multiply all that out, you see that these cows can lose a lot of blood in a day from a lot of horned flies. So it can be a real big loss. But again, it's not such a big problem in our dairies, especially in confinement, but it is for pasture dairies. And I know that there's some of those around, so it can be for them. But on dairies, this is kind of a unique concern that we have with the horned flies, causing this thing called summer mastitis. And you got a reference down here to an article from the University of Kentucky, if you're interested in reading more about it. This picture to the right here came from California. There was a dairy. So these are actually, I know they look like beef animals, but those are Holstein, Swedish Red, and Montbéliard crosses. So they look kind of like beef animals. But this herd had animals coming in with Staph aureus mastitis, and ended up being a big part of the problem were these cows out in the pasture. The bred heifers out in the pasture. So let me show this here. I'm going to play the video, and it's just a couple seconds, but you can see this cow throw her head up and see the flies fly from her. So that's if you're having heifers come in with mastitis, especially in the summer, but you can see it other times of the year too. I mean, we call it summer mastitis partly because of the flies here, and when we might see it when you think about it, if an animal gets infected and then goes through a winter, you might see it other times of year too, but you're going to see more of it in the summer and fall. And now we're going to move on to the stable fly. So here again is that picture of that stable fly's mouth parts. You can just see why they're so painful. That thing rips into the flesh, and it's really quite big compared to the other flies or mosquitoes. So it's a very painful bite. And then different from the horned flies that face down, the stable fly always faces up. And they tend to fly close to the ground. So they fly close to the ground, only 2 or 3 feet off the ground. So you see most of all of them on the legs of the animal, and you might see a few on the belly, but you can see most of it on the legs. But other animals, you see it at the top of the animal. So in dogs, this is actually called the dog ear fly because they bite the dog's ears. And if you see your dogs with bloody ears, that's frequently because of these darn stable flies. It's really interesting how they don't feed for very long, just 2 to 4 minutes, and only once or twice a day. So almost every horned fly that you see, those ones that live on the back of the animal, almost every adult that you see on the animal is every fly that exists. With stable fly, that's not the case. There's thousands more hiding in the grass because they only eat here for a couple minutes and then they fly off to other places. So very small percent of the population is actually on the legs at any one time. And they've done studies that look at how many it takes to be a problem, and it doesn't take very many because these bites are so painful and so much blood loss that and it disrupts their behavior so much that it doesn't take very many flies to affect that be an economic importance. So just another thing about the fly, you notice this one up here in the upper right, how its head's higher than its butt and how it's really full of blood. If you smash a fly that lands on you and you get a smattering of blood, it's probably one of these stable flies. It's probably not a house fly. It could be a house fly if the house fly ate blood, but it looks like it's full of blood. It's probably a stable fly. Another thing you look at is this mouth part that sticks out here. If you look here in this picture, you can see it sticking straight out here. That's that proboscis that's really going to be painful and really stick into the skin. And if you notice, the housefly does not have that. That's one way to tell them apart. Another way to tell them apart is that the rear end of the stable fly is down and the head is up. If you see one resting on a post, that's the way it'll be. It'll be like an airplane with its tail end down, whereas a housefly will be pretty much level with the surface. So control of these really, if we're going to treat the adults, you really need to spray the legs. It's really the only place these flies get. And so some people try to do it with pour-ons on the back, and that's just not going to be effective at all.
Good morning.
It needs to get down where the flies live. All right. I put breeding areas here in highlighted because I think it's the biggest part we don't do well enough on farms is destroying the breeding areas or treating with insect growth regulators. I'll talk about more of that in a little bit here, but the biggest thing is just to destroy where they're breeding. And in the resting areas, you can destroy and do sprays there, but that can be really difficult. If you've got trees and shrubs and or cornfields real close to your farm, they're going into those places and resting, and it's really hard to get them treated. So I think the most successful spot's going to be taking care of where they're breeding and destroying them. All right, so here's another picture of that hay feeder. Right around here is where you might find a lot of stable fly larvae because they just love that bedding. These interns over here, this is not a freestall barn, but these cows are eating out of the stanchions, and this feed builds up, and where that feed builds up and gets just enough water. So here where this intern is taking this, it's just wet enough. There's a huge number of maggots right here. And almost all the maggots we found there were stable flies, although some of them were house flies. Then right above here, there's a drip line that's keeping this wet. And it was really interesting because over here, we did not find any where it was too dry, any maggots there. And over here, right underneath the dripper, it was too wet. But in the zone right here, it was perfect for them, and there was a huge number of them. So one thing I suggest to people is that they keep this knocked off in areas like that. Look for them, you look for maggots in there, see if you find them there. And the first time in the spring when you knock that off is kind of a hard job because it's kind of built up and got hard over the winter. But then if you blow it off every week, you can do that with an air compressor with a blower on it. And you can it can be a pretty easy, fast job. So all these places here, if you go out to your silage pile and where there's big piles of extra silage or used bedding or even where you pile the grass clippings, if you look for maggots and those things, it's frequently going to be the stable flies that you find. You might also find house flies in there, but the stable fly really likes that kind of environment. This is a slide I took from another presentation we did on lameness. And the reason lameness and these stable flies come together is because it really changes their behavior. So if you see these cows up here on the right, this is a California farm. These heifers getting this huge bunch, and these stable flies come up and they'll affect these ones on the outside. So they're trying to get to the inside where they're not going to be as affected. And this behavior really can affect them. And we see that in milk cows, and they stand in the middle of the day when they should be laying down. And it's probably one of the reasons we get increased lameness late in the summer and the fall. This herd here is from Iowa. And if you see down here in the middle, these cows are bunching. There's just one straggler out here, but all the rest of them are down here. And that's because they're trying to get away from these biting flies. All right, now we're gonna talk about face fly just a little bit. So they obviously spread pink eye, and the other flies can spread pink eye too. And these face flies are fairly innocuous, right? They don't have biting parts, but both the house fly and the face fly, even though they don't have biting parts, they get bacteria and viruses and other germs on them and can spread that around. Probably one of the biggest risk factors for spreading pink eye. So it doesn't take very many to be a problem. So control these, obviously, on animal. It obviously, ear tags kind of make a lot of sense here. Sprays, oilers, and dust bags can work. These feed-through insect growth regulators can be useful, and the regular dung beetles too, which also be helpful with horn flies. But anything that can help disrupt those patties to get rid of the breeding environment. So here's a close-up picture of some face flies. You can see them that they even though they don't have these mouse parts, they get really close to the eye. And if you can see, if they were one animal that had pink eye, and they come over here and they land to suck up these tears, how they can be spreading the bacteria that causes pink eye from animal to animal. All right, I want to talk about house flies, and introduce a real fancy word up here, synanthropic, which means lives well with humans. So, pigeons and raccoons and some other animals kind of like to be around humans, seagulls, and flies are kind of like that way too. They kind of follow us where we go. They like where we put waste and how they like to reproduce there. These other animals could be considered that too, but truly house flies are really synanthropic, which kind of makes sense for its name, right? It's called the domestic fly. There's lots of pathogens that have been found in flies. And clearly they're a nuisance, right? Even though they're not biting, when they're just flying around and being around you, you don't like it, both as a human and as an animal. It's just not good. So it decreases the productivity of both humans. And then it's a nuisance for homes, right? So it's people in neighboring communities don't like to have a lot of the flies around. So the control of this one can be a little bit different. So the breeding areas, I put that in highlights again, destroy and insect growth regulators are the best way. You can affect these with the resting areas. They'll like to come in and rest high in areas. You can spray those at night. Spraying the animal itself, not going to be as helpful here. This is more of one where you actually treat the environment. This is probably the only one of these 4 flies where baits, it makes sense. They put a pheromone in there that attracts these, and they put sugar in there, and they have the mouth part that'll bring them in that'll attract them. But the other 3 flies here, these baits that we put out probably don't do anything with them. The stable fly, horn fly, or face fly. It's really only aimed at the house fly. And of course, you can use knockdown and foggers and misters too, which is commonly done, but in my opinion, and sometimes needs to be done. But in my opinion, if we're doing that and have to do that, we've probably failed up here and getting the breeding area destroyed. And that's where we're gonna have the best luck, is just doing that. So here's a house. This is kind of house fly area up here where they love to breed in this area. You probably see some stable flies in here too. This is a house fly larvae down here. And also an area where we find stable flies. They can develop in almost any kind of waste. If you see, if you have them growing up in your human garbage you put out there that you made, it's probably a house fly. Of these three, again, I said it's not obligated associated with livestock. It's could live anywhere, and it lives most of its life not on animals. It's the one you'll see flying around the feed very commonly and down the feed alleys, but it doesn't really need to be around the animals per se. All right, I'm going to talk just briefly about a success story with flies. This was a really unusual type of fly. It's a screwworm, and it's called this. It's got this fancy name, Cochleomia hominovorax, and this Cochleomia just means a fly that's screw-shaped or snail-shaped. So that's where the screw comes from. And then hominovorax is a really interesting one. That means man-eater. And if you Google this fly, you'll see a lot of pictures of this in other countries where it's actually in humans. So it's a pest of livestock, but a pest of humans too. But we did in the United States is we had it, especially in the southern United States. And some years it would get as high, it'd get as far north as Iowa late in the year. But these two scientists, Ed Kipling and Raymond Bushland, who got the 1992 World Prize for this, discovered that the females only mated once, and once they mated, they didn't mate again. And if they mated with a sterile fly, we got no offspring. So they made a bunch of sterile flies with gamma radiation, flooded the area with a bunch of adult flies, and they proved that it worked in the 1950s down on a Caribbean island. And then in the late 50s, they drove it off the Florida peninsula. And then through the next couple of decades, we drove it all the way off North America. So we do now keep it out of the United States. Panama helps us with that. We provide them with the flies and they keep it off, so we don't have to worry about coming back. Although in 2016, it did come back to the Florida Keys and was affecting the deer population there. But some alert wildlife specialists found it quickly, and we got rid of it very fast. Well, I just like to talk about this one because it's interesting to talk about sterile flies and how it used to be such a big problem and how we humans really have successfully gotten rid of this one, at least in our continent. Okay, we'll talk about treatment just a little bit. So the mode of action of insecticides. So all these over here on the left, the pyrethroids, the organophosphates, the neonicotinoids, and the spinosins, all work essentially as nerve poisons. And and I think it's important that we rotate the classes around and not use the same one all the time. Although we have a little bit of problem with that on dairies because we can't use organophosphates and we can't use neonicotinoids on animals. So it's a little bit harder there. Insect growth regulators are, I think, ones that we don't use often enough. They keep the larvae from growing, so they essentially inhibit the chitin synthesis. So it keeps the animal, the maggot from developing into an adult. And my favorite, though, is this high school kid with a shovel. At Elanco, we did a lot of things called fly audits, where we would walk around looking to see where the flies are growing and then come up with suggestions of what to do. And I think I ended up selling more shovels and getting high school kids jobs than I did selling our insecticides. Some people use these parasitic wasps, which that can be used on organic producers, so can be effective sometimes. The one problem with them is you got to continually put them out, and then if you do treat adult flies, you also kill the wasp. These alcinite traps down here, this is for stable flies. They're kind of attracted to this color, and they put a sticky stuff on here. This can be done with a way to monitor them, but also a way to control them. And they sell something similar on tape that can be helpful too. This one I find interesting. I've not really seen one of these, but I want to see one someday. It's a vacuum, and it kind of really makes sense for horn flies because the cows go through this. So this is, and then they can be there's a vacuum here that pulls all the flies off, and then it collects them, and then they just die. And the only fly it really makes sense from the horn flies, but it really makes a lot of sense for them. I'm going to just talk a little bit here about this veterinary entomology website. It's kept up by some veterinary entomologists, some state veterinary entomologists, and some other groups. It's just a really good source of information. If you look here at these things, you go home, you can find a pest, you can find a pesticide, you can find somebody, a professional, and then look for some resources. So here I've clicked on find a pest, and then you get a choice here of which animal you want to look at. And so I click here on pest of cattle, and I click here on the stable fly, and it gives us a little bit of blurb about stable flies and information about controlling them. And then here I show what happens if you click here where you find a pesticide. You can go to your state. So here I put in Iowa. You can go what kind of animal you're treating. So cattle, lactating, and then for stable fly. And it gives a list of all the different products that are approved for use in the for stable fly. And it gives here which class they're in. So if you're going to rotate, you can kind of use that to help pick out different classes and how to go about controlling them. Really, really good source of information. I just want to make a point here about ear tags, because this can be really confusing. All ear tags, pretty much all of them say good for 5 months, but almost all research shows that they're not good for 5 months of really being effective. And that's partly because of how things are regulated. The USDA regulates most of the things that the big thing we look at in animals is vaccines, the FDA for drugs, and then the EPA for pesticides. And there's some there is some crossover, and they have a letter of understanding between them of who's going to regulate what. But all three of these organizations have slightly different missions, and the EPA is more about the environment. So that's one of the reasons this 5 months is on there. It's more has to do with how long it lasts in there to be detected. But it's probably really only good for about 3 months. So I think that's important to think about if you're using these to control pink eye and growing calves out on pasture in the summer, or if you have animals out in the pasture, not to put them in too early. You probably want to put them in as you start to see the pressure of the flies, especially here in Iowa. If you put them in February, thinking they're going to be good for until the middle of the summer, that's probably not right. I would wait till you put them in May or June rather than putting them in March or April. I'm a fan of Gary Larson's Farsight, and I have a book where he talked about some of the development of some of his cartoons. This one on the right is the one that actually got printed, and it says, "I'm leaving you, Charles, and I'm taking my grubs with me." But in this book I have about when he developed it, he says, "This is one of those rare instances when I even found something sort of repugnant in the drawing. The grubs on the right just seem more palatable than these maggots." So if you see these maggots over here, I love these because they really look like fly maggots, and these look like flies. So I prefer this one to the left. I wish that's the one he would have used, but he didn't. But this is a lead in to be talking a little bit about the maggots and what they look like. So this is a maggot here. This is actually a stable fly maggot, and it looks like a worm. It's got a broad end, and then it's got a narrow end. This broad end up here, this actually is the mouth end, and this is the anus end, and these are actually breathing holes. They're not eyes. They kind of look like eyes, but they're actually spiracles, which are breathing tubes. So most of the flies we're going to find in decomposing bedding in a confined system are either going to be stable flies or house flies, and their positions and the shape of these spiracles is quite a bit different. So here's a house fly. They're real close together, and there's not much space between them. Space between them, one of these is wider than the space between them, and they look like D's. One look like a forward D and another one's a backwards capital D. And then the stable flies are more like triangles and quite a bit further apart. So it's just kind of fun sometimes to look at this when you go out and you show, if you find one of these, and most people have a camera where you can take a picture of it and blow it up and say, see here, this is one of those flies that's going to be because a biter. It's going to be a stable fly. And if you go out there and see which flies are growing in which spots can sometimes help you figure out what you could be doing differently. All right, so now I'm going to have a little bit of a quiz here, but no official quiz. Just everybody think about it. Which fly do you think this is on this cow? This heifer. It's the one that lives on them. It's small and really on the back, and a lot of them. So this is a horn fly. All right, and this one here, it's on the legs, and I can tell you this animal's in a lot of pain. There's a lot of stable. I gave it away. They're facing up and they're on the legs. So it's almost certainly a stable fly. That animal, that's a lot of stable flies for one animal to have. It's very painful. All right, so this was manure by the fence at the end of the freestall barn. So they're close together. And let's go back to which ones are close together. So it's a housefly. All right, and this one is from a spoiled feed pile. And it's really hard to see here on this one to the left. And the one to the right where it's blown up, you can see that they're far apart. And so this is a stable fly. And this one's kind of a trick question. This is from a cow pasture. So it's going to be either probably a horn fly, which is what I thought it was, because it's from a dairy that had from some growing calves that had a lot of horn flies on them. But this is actually a face fly. Face fly is the only one that has a tan cocoon. All the rest have reddish cocoons. Even though the spiracles kind of look like a housefly one. All right. So this is a riddle to your kids. Ask your kids tonight. What do a stable fly and the Eiffel Tower have in common? They're both parasites. And it's okay to moan now if you want to, for the stupid dad joke. All right, just a final thought on this. I think we spend too much time in general concentrating on killing these adults with the sprays and everything. And we don't concentrate enough on keeping a place where the eggs can develop and grow into these larvae. And I think the most important thing to do is to disrupt it, spread it out in the field, make it too wet, make it too dry, something like that. Each environment's going to be a little different on that. And so disrupt it where you can, and then use larvicides when that's not possible. And I've listed 5 of them here. And these go by different brand names, but I think they're all different. And some are feed throughs, and some are premise sprays, and some are both. But you kind of got to decide which one is going to be best for your situation. All right, so that's all I have, Fred. Are there any questions in the chat?
I'm not seeing any questions come through. Well, here's one. Can you comment on travel distance for housefly, stable fly, and horn flies?
Yeah, they can travel for several miles, but if there's a lot of flies around, they came from pretty close, because they'll be diluted out in the inner space. So they're coming from a long distance to be a little bit of a nuisance and to seed down the population. But if there's a lot of animals real close, a lot of flies, they came within probably a quarter mile. It's not further away than that if there's a really high population of them. And they can travel a little bit more in the wind, right? They'll get caught up in the wind and go a little bit further.
Okay, we've got a pretty good group, so if you would type your questions in, that would help us out. Jim asked, where should you put the environmental larvicides?
Where should you put them?
Yes.
Yep, yep. So, well, the ones that are feed through, of course. So the ones that you're going to help control with the horn flies and the face fly, that'll be in the feed. The others, I'd put them where you find the maggots but can't treat very well. So one spot's like in the cattle guard crossovers that are put there where the feed will fall through. That's really hard area to treat, and it's hard to get in there and clean that very well. It's a really nice area to do that. Big piles that are, so if it's compost piles, you don't have to do much about it, because if you're really treating the compost, the heat will kill them. But if you have a pile of manure that you can't get spread out, along the base is where it's usually about the right amount of dry matter to where the maggots are going to like to develop. But I would base it a lot on going out and actually looking and seeing where you find them, and then treating those spots where you find them.
Okay, our next question from Dwight. Will horn and stable flies be present on cows in tunnel ventilated barns with excellent airspeed velocity?
You won't, well, you won't see near as many. The flies do not like wind. So if you can keep the wind over a cow at 5 to 6 miles per hour, you will not see near as many flies on them. And we don't tend to see as many horn flies in that situation. You do see stable flies, and that will help keep them at bay somewhat.
Okay, question on your last slide. Should that read organophosphates? Is that what
Some organo. Yes, thanks for the proofreading that I left off an H. Yes.
Okay. Next question, do you see any new genetic technologies such as sterilization of the screw flies for other species in the future?
I don't know of any that's there, and that one is kind of unique to their species because they only mate once. So it's that was a kind of a special case that we could do that there. If anybody has any great ideas, though, it'd be great to develop something like that.
Sounds like a research project just waiting to happen.
It does, yeah.
Any tips on controlling flies around milking robot?
Well, I don't know if it'd be any different than other places. So I think probably most of the robot flies you're seeing around the robot are probably house flies. So there's things you can use to put on the walls, and both several different things. Some of the neonicotinoids and some of the pyrethrins that are both. I make sure they're labeled for the area around a barn, but they could both be used there. I think they both have attractants in them that attract the fly, and then they'll go to them and die and fall right there. But I'd be looking for where they're reproducing, and that's probably not right in the robot. That's probably out where the manure is stored close by, or in the areas around the freestall barn where the feed's developing, and that kind of thing.
Okay. Now I was intrigued when you said the housefly vomits and then consumes it back to get nutrition. Is that an acid, or how does that work?
Well, they have a very simple digestive system, so it's we're kind of lucky. We don't have to do that. Our saliva, we swallow it, it gets down with our food and our digestive enzymes, and it just goes down directly. They kind of have to vomit that up and lap things up and get it kind of pre-digested for them. So yeah, when you see a fly speck, when a fly lands and it vomits, the fly speck will be kind of a yellowish tan color, and the fly poop will be kind of a brown color. but if it'll be a black color when it's a stable fly, because they only eat blood, and it's makes a lot darker, makes a lot darker fly speck. So now when you go see fly specks now, and you see a tan one, it's, or a kind of a cream colored orangish one, that's a vomit speck, and a brown one is the poop speck. And the poop specks tend to be stretched out a little bit longer. They're more like a streak, and the vomit's usually a circle.
Okay, that kind of leads into a question I had. I have several dairymen who put up the 3x5 cards, just tack them on posts in the barn, and they use that as a count for flies. They can count real easily where there are more fly specks this week than last week. Is that a good practice to get into?
That's an excellent practice, Fred. I should have had a slide in about that. Yes. And there's several different schemes for doing that. And I think when you put down it's hard to come up with an exact number that you should recommend, but you kind of know where you start and know whether you're making an improvement or not by doing it the same on your farm every time.
Okay, do we have anybody else who's got a question? Go ahead and put it in the chat box. If not, can you give your thoughts on the feed through? So is the efficacy such that you recommend those?
Maybe. I think for horn fly and face fly control on pasture, I'm a bigger fan than I am for house fly and stable fly control. When you think about where stable flies like to reproduce, right, in decaying, high fiber forage type material, we're not going to hit all those spots with feed through. And when you think about too, that stable flies tend to reproduce in older manure, and once it's been months and months sitting there and kind of rotting is what they like, and a lot of that chemical is going to be gone. So I've had quite a few people asking me, I've started feeding these feed throughs, but dang it, we still have a lot of these dang biting flies. And I think it's probably the wrong. It may be somewhat helpful, but it's probably the wrong tool at the wrong time for those flies, or at least to be 100%, at least to be as effective as we want it to be. I'm a bigger fan of destroying the habitat and then treating with a topical topical insect growth regulator instead of a feed through. Does that make sense?
Yep, sure does. I've got one more question here. High path in dairy cows is a big topic right now. Could flies be a vector on farm?
Well, first of all, I was hoping this was going to be a reprieve from talking about high path, but
Okay.
It could be potentially, but probably not as big as direct bird spray, birds bringing it in, or direct from animals. Certainly, it should go on the list of another organism, another reason we should control flies, but probably not as big a deal as it is for controlling birds would be a bigger deal than controlling that. And there is a talk this afternoon if people are interested in that the milk producers are putting on at 3:00 today.
Very good. Well, we've had several comments about the good program and good information. I'm out of questions. I'm not seeing any more come. At this point, I'd like to thank you again for putting the program together and presenting for us. Folks, I want to have you aware that you will look in the chat and you'll be able to see that we have this set up to be archived on the Iowa State Dairy Team website. And there's also a Qualtrics evaluation. If you could take just a moment and let us know, answer those 4 questions, that really does help us put together more and better programs. So folks could, even if they're viewing in the archive, then take a moment and look at the survey. So thank you again, Dr. Jardon, and this will conclude today's program.
Thank you for